So we've already solved systems by graphing and by substitution. This is our new method. It's going to be called elimination. And basically what we're going to be doing is eliminating one of the variables. And that's why it's called elimination. So linear combinations or elimination, because we're going to be combining our two equations. That's why it's called combination as well. The steps for solving is first you need to get both equations in the same form. I suggest putting them in standard form. So that would be ax plus by equals c, where a, b, and c are your numbers and x and y are your variables. Then, if need be, we're going to multiply one or both equations by a value that will make one set of opposite coefficients. So, if one of my coefficients was 2x, what would have to be the opposite of that? Yeah, so if I have negative 2x, a positive 2x. Those would be opposites, okay? No, just opposites, not the reciprocal, okay? Then we're going to add the equations together, because if I add 2x plus negative 2x plus 2x, I would get 0, and that's what we're trying to do. We're trying to eliminate. Okay? So I'm going to add the two resulting equations together, and then we're going to solve the equation. Then we're going to substitute that value into any equation to solve for the other variable. Okay? So, are these both in standard form? I have x plus y equals 3 and x minus y equals 1. Yes. All right. Are x and x opposites? No. What about x and negative x? Yes. So I don't need to multiply by a number. So now I'm just going to take my two equations and add them together. Okay? So x plus x is 2x. And y plus negative y, or y minus y, is 0. So those eliminate. That's what we're trying to do. And 3 plus 1 is 4. And I'm going to divide by 2. And x equals 2. So now that I know x, I need to find y. So I'm going to take this x value and substitute it into either one of my equations to find y. So I'm going to take the top one because it's all positive numbers. So instead of x, I'm going to put 2. And I'm going to subtract 2 from both sides. So y will equal 1. So my ordered pair will be 2, 1. Okay, so I have 5x minus 16 equals negative y, and negative 5x plus 3y equals 8. Are these both in standard form? No. So the top one, I need to get it into standard form. So currently I have 5x minus 16 equals negative y. So I'm going to add 16 to both sides and get 5x equals negative y plus 16, and add y to both sides. So that would be 5x plus y equals 16. And the reason why I'm fast there is because we've already talked about changing equations into other forms. So this is now in standard form. So, looking at my x's, are my x's opposites? Yes. So, I don't need to multiply by anything. So I'm going to take my two equations. So I have 5x plus y equals 16. And then I have negative 5x plus 3y equals 8. I'm going to add them together. So 5x plus negative 5x, or 5x minus 5x, is 0. So those cancel out. y plus 3y is 4y, and 16 plus 8 is 24. Then I'm going to divide by 4, and y will equal 6. So now that I have y, I need to find x, so I need to substitute it into one of my equations. I'm going to substitute it into this one here because it's nice and neat and y by itself. But you can substitute it in anything, it doesn't really matter. So I have 5x plus 6 equals 16. I'm going to subtract 6 from both sides. 5x is going to equal 10. Divide by 5, x is going to equal 2. So my ordered pair will be 2, 6. Okay, so let's look at the next one. Okay, so I have 2x plus y equals 5 and x plus y equals 4. Are these in both standard form? Yes. Is 2x and x opposites?
No.
No. Is y and y an opposite? No. So I need to choose one of my variables to multiply by a number that will make it an opposite. Right now, y and y are by themselves, so I can multiply it by -1 to make it an opposite. So I'm going to choose the bottom one because it just has less stuff though. So I'm going to take x plus y equals 4, and I'm going to multiply it by -1. Okay? So that's going to become -x minus y equals -4. So now my y's are opposite. So I'm going to set up my problem. Elimination problem. Add them together, so 2x minus x is x, and y minus y is 0. That's what we're trying to do, eliminate. And 5 minus 4 is 1. So x equals 1. Now I need to find y. So I'm going to take one of my original equations and substitute an x. So I have 2x plus y equals 5. So I'm going to substitute in 1 for x and solve for y. So I'll have 2 plus y equals 5 minus 2, y equals 3. I could have substituted in my other equation and I would have gotten the same answer. So my ordered pair is 1, 3. Alright, so I have 2x plus 5y equals 34 and 2y plus x equals 14. Are these both in standard form? No, I need to rewrite my bottom equation having x plus 2y equals 14. We can change the order because of the association property that we learned at the beginning of the year. Alright, so now I have a 2x and an x, so those are opposite. And I have a 5y and a 2y, so those are not opposites. So I'm going to have to multiply one of my equations by a number. Okay, so right now I have an x here and I have a 2x. What can I multiply x by to get me a -2? -2. So I'm going to multiply this entire equation by -2. So -2 times x is going to be -2x. -2 times 2y is going to be -4y. And -2 times 14 is going to give me a -28. So now that I have opposites, I can set up my equation. So I have 2x plus 5y equals 34 plus negative 2x minus 4y equals negative 28. So 2x minus 2x is 0, so we're trying to eliminate there. And 5y minus 4y is y. And 34 minus 28 is 6. So now that I have y, I need to find x. So I'm going to substitute it into one of my equations. That bottom equation right here looks pretty nice. Or this one that we wrote out here. So x plus 2y equals 14. So instead of a y, I'm going to put in a 6. So if x plus 12 equals 14, subtract 12, x will equal 2. So our ordered pair will be 2, 6. Yes.
Can we put the y into the equation that we multiplied by -2?
You can
Or does it have to be one of the original equations?
I don't know. Let's see. That would be, what's negative 4 times 6 is negative 24. Add that to the side, so that would give me a negative positive 4. No, 24. No. 24 plus 28 will give me negative 4. Divide by negative 2 will give me a positive 2. So yeah, you can put it into any of the equations. Okay? It wouldn't matter. I think it says that, yeah, substitute the value into any equation to solve for the other variable. I just chose that one because it was the easiest. I like things easy. Okay, so I have 8x plus 5y equals 6, and 3x minus 2y minus 10 equals 0. Are both of them in the same format, standard form? No, the bottom one, I need to add a 10 to both sides. So I have 3x minus 2y minus 10 equals 0. I need to add 10 to both sides. That will be 3x minus 2y equals 10. Now they're both in standard form. Okay, so I have a 3x and an 8x. Are those opposites? No. I have a 2y and a 5y, or negative 2y and a 5y. Are those opposites? They're opposite signs. Are they opposite numbers? No. Okay, so they are opposite signs though. So I can multiply both of them, my equations, by a value to get them to be the same opposite numbers. So what can I multiply? I can multiply 5 by 2 and 2 by 5. So I'm going to take my entire equation, 8x plus 5y equals 6, and multiply it all by 2. So that's going to give me 16x plus 10y equals 12. And then I'm going to take my equation 3x minus 2y equals 10 and multiply it by what? 5. To get 15x minus 10y equals 50. Now I can set up my system. So I have 16x plus 10y equals 12 plus 15x minus 10y equals 50. So 16x plus 15x is 31x. 10y minus 10y is 0. And 12 plus 50 is 62. Divide by 31. X will equal 2. So now that I know x, I need to, yes? Now that I know x, I need to find y. So I'm going to substitute it into any of my equations. I'm just going to pick the top one. So I have 8x plus 5y equals 6. So instead of y, instead of x, I'm going to put in a 2. I need to find y. So that's going to give me 16 plus 5y equals 6. subtract 16 from both sides, so we get 5y equals -10. Divide by 5, y equals -2. So my ordered pair will be 2, -2.
I got -3 and 62.
16 plus 15? Fifteen plus 15 is 30.
Oh,
One more.
I subtracted 12. I subtracted. I did 12 minus 15.
You mean 16 minus 15?
No,
Where would you get 12 from?
right there. Everything
This? Why would you subtract that? Those aren't like terms.
No,
From 50.
Oh, no, those are positive. You're adding. You're adding the whole thing together. Okay? Alright, I'm confused. Alright. So, we have 4x plus 12y equals -24 and 2x plus 6y equals -12. Do we have them in the same format? Yes. Do we have opposites? No. But I can multiply 2x by -2 to get it to -4. So I'm going to take my 2x plus 6y equals -12, and I'm going to multiply it by -2. So I'm going to get -4x minus 12y equals 24. So now I'm going to set up my system elimination problem. So 4x plus -4x, or 4x minus 4x is 0. And 12y plus -12y, or 12y minus 12y is 0. And -24 plus 24 is 0. So 0 equals 0. Does 0 equal 0? Yes. So that is a true statement. So what do you think this is? All real numbers or infinitely many solutions? Or all real numbers. So that means that any ordered pair that you substitute in here would work. Technically, if we rearrange these problems, they are the same equation. All right. All right, so we have a your turn here. So, are they in the same format? Yes. All right. What should I do? How can I make them have opposites? Yes.
Multiply the top one by 3.
Yep. I can multiply the top one by, no, you want to do +3 because you want it to be the opposite. This is -3. So we want to do the opposite. So I'm going to take x plus 8y equals 28, and I'm multiplying it by what? 3. So what am I going to get?
Bx plus 12y
Equals what?
84.
84? All right, so now what do I need to do? I need to set up my equation, right? So I'm gonna have 3x plus 24y equals 84. And I'm gonna add negative 3x plus 5y equals 3. I'm adding. So 3x plus negative 3x is 0. And 24y plus 5y is 29y. And 84 plus 3 is, and I'm going to divide by 29. And what does y equal? Alright, now that I have y, what do I need to do? Okay, which equation do we need?
First one.
The first one, the original first one probably?
Yeah.
So 8 plus, or x plus 8y equals 28. So instead of y, what am I putting in?
3.
3. And what is 8 times 3?
24.
So I'm going to subtract 24 from both sides. So yes, x is going to equal 4. So my ordered pair is 4, 3. Alright, are they both in the same format?
Yes.
Do I have opposites?
No.
No. So what do I need to multiply by?
Negative 1.
Do we multiply the top or the bottom?
Top.
Sure. So I have 2x plus 6y equals 54, and we multiply the whole thing by negative 1. So we get negative 2x minus 6y equals negative 54. So I'm going to set up my problem. So I have negative 2x minus 6y equals negative 54, and then my bottom equation, which is 2x plus 6y equals negative 18. So negative 2x plus 2x is 0. And negative 6x plus 6x is 0. And negative 54 minus 18 is
Negative 17. No solution.
no solution.